Okay, here we have 4 more problems. We'll do 7, 8, 9, and 10. Gosh, I have so much fun with these. Cosine squared of pi over 2 minus x. Well, the cosine of pi over 2 minus x is the sine of pi over 2 minus x. So the cosine squared makes sense that it would be sine squared. Let me show you. So this is the same thing as, and I don't ever do this on a regular basis. I'm just going to show it to you once so that you can see why it works. And I'm going to do a lot of tapping here as I undo what I just wrote because I don't want those parentheses there. So cosine of pi over 2 minus x. So see, I just expanded out and I've got the same thing multiplied by itself. That's what the exponent of 2 means. And we know that this right here is just the sine of x. So I'm going to have the sine of x times the sine of x, which is sine squared of x. So that's how I'm going to say that this expression is equivalent to this expression, sine squared of x. And then I have that over cosine of x. And I can simplify a little bit of this. I don't need both of those signs in the numerator. So I'm going to split them up. Sine of x times sine of x, and then times 1 over cosine of x. I don't usually do that. I usually just write this cosine of x underneath the sine of x, sine of x. So something like that. But I wanted to show you that you can separate them out as well. It all depends on how you need to see it. Sine of x over cosine of x is another way of saying tangent of x. So we had step 1. Now we have step 2. Step 3 would be sine of x times tangent of x. And then our final answer is exactly that. Sine of x times tangent of x. And that's a little bit more simple than having the exponent of 2 in that numerator. And then, of course, you don't have any denominators, so it works out very nicely. Now, number 8, cosine squared of y over 1 minus sine of y. We're going to have to go back to our algebra skills to do this problem. Cosine squared of y, there's 2 different ways to do this. I'm going to show you both ways too. Cosine squared of y is another way of saying 1 minus sine squared. So cosine squared of y is 1 minus sine squared of y. That's step 1. Now, we can't cancel addends out. We know that. You can't just do that. For instance, 2 plus 4 over 1 plus 2. You can't say, well, 4 over 2, that cancels to be 2, so this is 4 over 1. We know that that's not true because 2 plus 4 is 6, 1 plus 2 is 3. We should have gotten 2 as an answer, not 4, right? So you can't cancel out addends. As much as we're going to want to do that when we're talking about algebra, we can't. So we have to go back to factoring. So 1 minus sine squared is 1 plus sine of y times 1 minus sine of y. We've got the difference of squares. And then look at that. Look at that. We've got 1 minus sine canceling out with 1 minus sine, and our final answer is 1 plus the sine of y. Now 1 plus the sine of y is not cosine because we don't have the squared. Remember, they're called Pythagorean identities, and Pythagorean identities have squares. Okay, they have squares. If you have questions on that, definitely ask. There's another way to do this problem, and I am going to show you because, I love this math. Cosine squared of y over 1 minus sine of y. Not just because I love it. I'm going to show you because this is kind of a handy little trick that you can use when you're proving identities, which we'll be doing. When will we be doing that? In 5.2, I think. In the next, in the next lesson, we'll be proving identities. And this right here is a handy tool. I can multiply by the conjugate. Remember when you're rationalizing denominators, think of it as rationalizing a denominator. So you're going to multiply by the conjugate to create that Pythagorean identity. But if I do that in the denominator, I have to also multiply the numerator so that I'm multiplying by a factor of 1. So I'm not changing the value, I'm just changing what it looks like. So in the numerator, I have cosine squared of y times 1 plus sine of y. And in the denominator, I now have 1 minus sine squared of y. And we all know, this actually would be step 2, we all know that cosine squared of y is the same thing as 1 minus sine squared, and that 1 minus sine squared is the same thing as cosine squared. So I'm going to change the denominator to be cosine squared of y. And I'm going to show you again, sine squared of y plus cosine squared of y equals 1. If I subtract sine squared of y from both sides, so that I now have 1 minus sine squared, 1 minus sine squared is equal to cosine squared. So that's where this substitution is coming from. They cancel out, and our final answer is 1 plus sine of y, which is what we had in the previous example. Okay. Go ahead and try maybe 9 and maybe 10, thinking of factoring a greatest common factor or factoring a difference of squares like I've shown you above. You're going to have all sorts of things just kind of thrown at you in these different types of problems where you'll be having to rely on your skill set and that toolbox of techniques that you need to have to be able to simplify these expressions. Meanwhile, I'm going to solve it. So I'm going to factor out secant squared of x, which is going to give me tangent squared of x plus 1. And I'm not going to solve it, I'm going to simplify it. And then my next step would say, well, I tan by the c, so secant squared of x times secant squared of x. Well, that's going to give me a much simpler answer of secant to the 4th power of x. So we went from 2 terms all the way down to 1 term with no fractions. Beautiful. Next example, secant to the 4th minus tangent to the 4th. I'm being a little sloppy with how I'm saying this. I should say secant to the 4th power of x minus tangent to the 4th power of x. That's a difference of squares. So secant to the 4th power of x is a square of secant squared. So I can rewrite this as secant squared of x plus tangent squared of x times secant squared of x minus tangent squared of x. Now, I tan by the c. I tan by the c. I'm going to manipulate that. Secant squared minus tangent squared. Well, look at that. This right here, it looks like I have a little negative in there, don't I? It's not really there. It's just my pencil. That right there is the same thing as 1. So now we have secant squared of x plus tangent squared of x times 1. And there's really not anything else that you can do here to make this any more simple. Nothing's negative. We don't have any fractions. Nothing simplifies. So it's just beautiful the way it is. Secant squared plus tangent squared. Now, you might see, someone say, well, I know that secant squared is 1 plus tangent squared. So can I just say 1 plus tangent squared of x plus tangent squared of x? That would be 1 plus 2 tangent squared of x. Yes. So one of those 2 answers could be a very valid answer that I would accept on a test or on a quiz.